All right, question number 3. We want to state the values of lambda and t for the Poisson process. It says the flaws in a piece of timber occur at a rate of 0.07 per linear foot, and the random variable x is the number of flaws in the next 19 linear feet. Okay, so similar to problem number 2, they give us lambda, the average number of flaws, 0.07 per foot, and then they tell us which is going to be our interval. This time it's a length and not a time interval. We want to find the number of flaws in the next 19 feet. So our t in this case would be 19 feet. It's important to make sure those match up. So we have 0.07 and then 19. All right, now question 4, we have 4 parts. It says a random variable x follows a Poisson process with the given mean. So we're using the Poisson distribution, but we're using mu for mean, so they've already done the lambda and the t to come up with the mean. So just recall in the text they told us that the mean was equal to lambda times t. So they've already applied those parameters. And we're going to find the probability that we get exactly 4. We're going to find the probability for part B that x is actually less than 4. We're going to find the probability that x is greater than or equal to 4. And we're going to find the probability that we are between 4 and 6. Now, we're going to use technology to do all of these. So we're going to do get more help. We're going to go to StatCrunch. Go to Stat, Calculators, and then we're going to go down to the Poisson. So you have a standard, you have between, and then down here you have different options. So the first one we want to do equal to. The mean for this problem was 6. Okay, so I wrote that. The mean is 6. And we want to find equal to 4. Okay. And so when you do that, it's going to apply this to the Poisson formula. So we're not using the formula, but if you want to recall, probability x is equal to some x value was equal to the mean to the lambda t times power x over x factorial. And then we have e to the negative lambda t, which this is a process. So the computer is doing all of this for you and plugging it in, and we get to 4 decimal places, 0.1338, but the 5 after the 8 will round up to a 9. So we're looking at 0.1339. Now less than 4, what the computer is doing is from 0 up to 4. So that means we're finding the probability of 0, the probability of 1, 2, all the way up until we get to 4. So it's, this one just did 4 by itself. So this one's adding 0, 1, 2, 3, and 4 together. And this time I'm just going to change this to actually less than 4. It's not including 4. It's just going to 3. I'm sorry. Fix that. So I could have just done one more probability of 3. So it's just doing 0, 1, 2, and 3. Less than 4 does not include the 3. So we're just going to say less than 4. And it does it automatically. So we got 0.1512. greater than or equal to 4. So that would be everything to the right. Now, greater than 4, that would be like 4, 5, 6, 7, 8, all the way up to infinity. The best way to do that, okay, so instead of doing this probability of 4, 5, all the way up to as many as possible. So we couldn't really do that. So what happens is we just do 1 minus the opposite. So instead of going 4 and above, we can do 1 minus less than 4, which will be 3210. This number right here, that will give you 0.1512. So 1 minus that will give you 0.8488. Now, I'm going to do this with StatCrunch, but that's essentially what you're going to get. That's some of the properties they want you to be able to understand. So I'm going to say greater than or equal to 4. And you see it gives us 0.8487. But when we round up, that 9 will round that 7 to an 8. And that's what we got here. So 0.8488. And then the last one is going to be between 4 and 6. So we would just come up here and click between. And then we would put 4 as our lower value and 6 as our upper value. So between 4 and 6, and that gives us 0.4550, but that will round up to a 1, so 0.4551. Now there are tables and charts and things that we can use, but not all of them have all the means that we might want. So using the StatCrunch will get you there every time. So we're going to enter those answers here. 0.1339, 0.1512. This is going to be 0.8488. And between was 0.451, sorry, 455